Hello and welcome to the Data Show. It's Wednesday, July 8th, and my name is Yufeng, and this is Felipe. We are thrilled to have you on today. Thank you for everybody for joining us. And Felipe, what do we got for the people out there today?
Oh, today is going to be a really cool day because today finally we're going to go deep into time series analysis. I know that we teased that we were going to do that last week,
Something
two
like
weeks
that.
ago. But then, yes, the last time we used that time to prepare the whole scenario to have awesome time series, have our environment ready. We did that. I hope everyone enjoyed that. And are we ready to pull this off
I hope
today?
so. As they say, preparation is everything.
Yes, I'm always super happy to see our friends connected online.
Definitely.
That's
Welcome, everyone.
always great to do a live show. Yes, thank you for your questions. I love all GDG Cloud London always present with Saverio and the whole team. So Alessandro too, thank you very much for staying up late. That's why we do the show at noon so we can reach
That's
Europe
right.
too.
Welcome Europe, welcome the West
Yes,
Coast. I guess folks eating lunch and dinner, similar meals.
same thing. Yes. Um, So let's quickly review the end result of what we want today. Did you see my blog? The blog post I published basically
Yeah,
yesterday.
this tweet you just sent out the other day. Yeah, it looks pretty good. I really
Yes.
like that animation.
Oh yeah, yeah. If you click on the blog post, well, I also put it on Twitter.
It's the place to put the things, right?
But oh yeah, just to talk about this
Yeah.
little animation, you can see that half of it is real data, half of it is projected data. And you can see like Clojure is going down, Julia as a language is going up on Stack Overflow. Then you see Scala that gets the same, very stable, Swift is stable. R is stable too, but increasingly gets more attention. JavaScript gets way more attention than them. And then Python is the one that's growing.
Can't stop the snake.
It's yes, the snake is going up. But what is cool here is that we can use BigQuery and we can use ARIMA to take a time series. In this case, it's the attention that each tag gets quarter by quarter on Stack Overflow, and we can project it into the future.
Yes.
And
The
that's really,
future
really cool.
is now.
And yes, like no one knows the future. But the projections are still interesting. It tells us not what's going to happen in the future, but it can tell us a lot of what are the trends right now. And if we amplify them, then we can act on it.
So let's take a look at, I guess, the data, right? See how we can get to these charts.
Sure.
The next step.
Sure. So let me show you my blog post first. If you scroll to the first tweet
and I
there.
just realized we haven't been showing them these animations, so let me go to that.
Oh,
that's the
yes,
that's the animation we're looking at right now. So
people can understand what I'm talking about.
Yes.
Yes. Yes. Now we are showing the screen right there. That makes things much better.
Now we know what we're talking about. So folks on the live chat, feel free to tell us when we forget to change the view.
Yes, at least people were interested enough in what we were saying. So if you go back to the first tweet on this tweet thread,
yeah, let's take a look at this.
You will find the blog post.
And I'll drop that link in the chat for folks to follow along.
Perfect. So that's the animation I was telling people about. Like that's Clojure versus Julia. Julia's growing, Clojure is not. Scala is going up. And then the animation, people cannot see the animation. Oh yeah, Swift, R, people love R. Then JavaScript is way bigger. But the one that's crazy is Python. Python up and to the right all the way. And it was in 2018 when Python got more popular than JavaScript. Yes. So, and there are a lot of other interesting trends that you can find here if you keep scrolling. But let's play a little bit with the code. I love showing this chart first because basically it's showing this is the data that I know.
This is history. This is history now.
Exactly. But these are the top 10 tags of June 2020. Right. Interestingly enough, you can see that there was not a big change in Stack Overflow trends between March and June.
Yeah, most things were pretty flat.
A lot of things. Exactly. Like a lot of things happened in the world, but attention-wise, all the top languages continue their own trends during that quarter. Interesting fact. But I'm showing just half of the data here. I'm stopping in this chart on Q2 2020. And then on the next chart, if you scroll a little bit, these are the same trends looking into the future. And again, whatever data you have in your own business, in your own projects, you're analyzing data, you probably have time series. Expanding the time series into the future can show you a lot of what's happening. So you can see jQuery is going down and down and down while C++ stays stable. So probably in 2023, jQuery is not going to be a top 10 tag.
Yeah, that's crazy.
So the next chart I put here is, let's look at the top 10 tags of 2023 according to the
projections. Oh, you resort them. Okay.
Yes. So basically now I'm just looking at top 10 based on their projected ranking in 2023. And here you can see two tags that are pretty small, didn't have a lot of traffic 3 years ago.
Yeah.
But if they continue the trend, they will be a top 10, and those are Angular and React.js.
Interesting. So which one is, because there's a lot of shades of orange here. Do you see that towards the bottom? Like CSS, PHP, React, and Android are all sort of orange-ish. And so it's a little bit tricky to tease out which one is which. Like this pink line is Angular, but I can't really tell which orange line this one is and which orange line this one is. And they're very important, right? Because one is coming down and one is coming up.
Yes, you are correct, sir. So Data Studio tries to give each tag a different color, but because I have 15,000 tags, Data Studio kind of runs out of colors. And I could tweak it by hand, but then it's too much effort. But at least you can see that on the right side, you can see the tags listed in the same order that they are on that ranking on Q2 2023.
That's the
so you can see at least
right? Is like I literally can't tell which orange line is on top because they're coming together in 2023. Do you see that? Yeah. So when we get to the live chart, we'll be able to really see it clearly. So that's what I'm.
For sure, with the live. Yeah. But then you know that Angular and React.js were not there in the previous chart. So Angular and React.js are the ones that are showing the most growth. And of course, we can play with the live chart, and that's when things get a lot more interesting.
Definitely.
And I also charted some other interesting threads.
Angular versus React. Okay, so this answers my question.
That's what you wanted to know.
What I was curious about, right, is then if these two are Angular and React, then that means this one is Android, the decreasing thin orange line. Interesting.
Yes. We could chart Android.
Right, iOS isn't even on this list, so that's telling.
Exactly. But yes, React and Angular, they are at the same place today. But if we continue the trends, we can see that React.js is kind of running faster. You can see that, you can project it, you can get it into your data just by running this time series
predictions. It's interesting that we're at this kind of crossover point right now, and it'll be very interesting to see what happens in the next kind of 6 to 12 months as kind of this plays out to see if these predictions hold true, like which direction things are trending, and if the fact that they are crossing over or are close together influences the future, right? Because before it's very different. And so if someone were to say like, oh, which one should I pick? And the fact that one is more popular convinces them to do it, to take that, right? It's like a self-fulfilling prophecy. But if they're dead heat and even, then that might change the dynamics of framework selection.
Oh, yes. What happens when we cross the streams? That's a very good question.
Something like that.
Yes, we have to follow those rules. And I know you love machine learning, so TensorFlow, Keras,
thank you.
PyTorch.
Yes, thank you for including this bit.
Yeah, TensorFlow kind of won. And then Keras and PyTorch also won. Like, you can see that they are very, very healthy.
It's interesting how parallel
on the bottom.
You know. Yeah, on the bottom we have MXNet and Cafe. I mean, Cafe is effectively retired at this point, so that's not surprising.
Yeah, but it's fun to see how Cafe had captured some attention in 2017, but it got nowhere by it down. And then MXNet, it never got any attention. Sorry, MXNet. And that tells you a little bit of the power of the clouds. Like, there was one cloud that was not Google Cloud that said MXNet is our future. That didn't work.
Yeah, it takes more than just a proclamation. You need a community.
Yeah, exactly. You need a community. You need developer relations. Yay! And you need to have a great product too. And you need someone doing an adventures in the cloud kind of show, like Yufeng. AI Adventures in the Cloud. Or what was?
I think it's just AI Adventures. We'll just call it that.
Yeah, AI Adventures. Thank you. Okay, upcoming languages, and now we will get to the code just to show people how we did this. Swift, Go, Haskell.
And Haskell has just always been kind of hanging out, chilling. Yeah, it's always just been.
Yeah, the growers are Kotlin and Go.
Go is going.
You can see some real.
Poor Ruby.
Go is going up. Yes. So let's rebuild this data on your side now. I want to show you another chart, but let's spend some time rebuilding the data. So let's go to the handy Cloud Shell.
My Cloud Shell is handy. No waiting times this time around. We got it ready to go.
Yes, you have DBT installed. We created the project last week. So let's go to the folder where you did our DBT work last week, which was code snippets. That's my repository.
Very generic name, very hard to find, but yes.
Yes. Stack Overflow DBT. Stack underscore underflow.
Underflow, overflow, you know, it's either way. Those are the...
Good question. Underscore overflow. Now update this with my latest code. If people don't know what we are doing right now, watch our show from last week where we did this step by step. I made some changes, renamed some files, but we can just run DBT run. So we create.
Well, this still doesn't exist because I never got around to adding it to my shell, and I can never remember what it's called. Here it is.
But is it in the history of your shell? If you
I mean, I've run so many things since. Here.
But yes, there it is. You run so many things that it's only three commands back there.
DBT, what do you want to do? Don't we need to go into our models folder?
Just run.
Do we need to go into our models folder?
No. Now that we're in the DBT project, this should run, and not everything will run. And okay, I found this problem before, and I know how to fix it. So this is the part where we show people how to fix this problem when they run into this problem. Like,
I don't have my Python environment activated yet.
Yeah, no, just do pip3, pip3.
I'm pretty sure. I don't have Python involved in this. All right.
No,
I'm just kidding.
Don't just click enter. Pip3.
uninstall
DBT-core.
Interesting. Oh, this is because I accidentally installed DBT last time.
I know I ran into this problem in the Cloud Shell, and I uninstalled DBT Core. I reinstalled DBT BigQuery, and things work.
Weird.
So now pip3 dash user install upgrade.
I always write update by accident, and then I get the error, and I have to do it again.
Install DBT dash BigQuery.
Cool. No such option dash user. That's always nice.
When did that happen?
No idea. It has to come after install.
Okay. I'm glad that you could just copy paste the line.
This is why you take notes, right?
Good. And now let's run DBT run.
Now we can run DBT run.
And we are going to recreate the tables. And in the meantime, let's go check the code, because not everything will run, so we need to fix some things. See, now we are rebuilding the first model. It's running a merge, so it was super fast, because we're going to have some problems here. We have the top tags.
Let's go over to your GitHub, I guess.
No, I would love for you to go on your Cloud Shell to your editor. So let's find these files. And we can see that we had problems running the prediction code. Models, and go to predict trends and predict top questions. Okay, so let me tell you what's happening here. DBT is really good working, creating tables, creating views, but DBT still doesn't have a native way of creating BigQuery models.
BigQuery models, not the DBT model.
Exactly.
Different, yeah, we're overloading the term.
Yeah, this is how do I create a machine learning model inside BigQuery. It doesn't have a way to materialize them. Some people are creating I've seen some proposals, but since I'm still using plain DBT, I had to write my own code on how to do this within a table. Within a DBT, how do I create a BigQuery model within a DBT
models in models.
Yes. But the first thing that you can see here that's pretty interesting is how we create a model in DBT. In BigQuery, sorry.
Yes.
Which is the line, create or replace my model. And this is my model that will basically, we are telling BigQuery, do an ARIMA model. The ID of each time series is the tag.
Okay, so that's the tag column.
What we are, the number that the time series value is basically the ratio. This is the ratio of attention that each tag is getting each quarter on Stack Overflow.
Okay, so you've pre-processed that basically to be the ratio. Like you've created this
Exactly,
column.
That's what we did. Yeah, that's what we did last week. Basically, it's interesting to get the number of page views, but the number of page views can change a lot depending on the environment. But the percentage of attention that each tag gets, it's way more stable, as you can see in the chart. And of course, this is a time series, so a time series has a time component, and in this case, it's the quarter.
Perfect.
And that's...
No, I said perfect.
Yeah. And basically, this is all the code that I need to train a time series.
Gotcha.
Now, you might notice that I'm doing some magic there with the date. That's because we just launched ARIMA in BigQuery. It worked really, really well. except when you have quarterly data.
But that's exactly what we have.
Exactly. I have quarterly data. So because my predictions were not good with quarterly data, I'm transforming my quarter by quarter data into day by day data.
How do you mean? Let's see if I can sort this out. We're taking the date difference of the quarter that is coming in, so that's still quarterly data, and you're making a diff against the start time. So you're basically counting or the amount of time by quarters since the start. So this should give us a number, interval date diff. So it's a day. Are you converting the quarters into days? So each quarter is counted as 3 months or 90 days, give or so?
So basically what that part is doing is I take any arbitrary date. 2017, there is an arbitrary date.
Oh, it didn't matter what you picked.
And I'm going.
It did not matter what the date was?
Yeah, the number there is arbitrary, but I'm counting the number of quarters between the arbitrary date and the quarter that I have.
As long as it's in the past. It doesn't matter.
It doesn't matter. It can also be in the future. It doesn't matter. It works. I will get an increasing integer that's basically how many quarters between this date.
So you get like so in this case you would get like 3 or 5 or 6, 7, those kinds of numbers? Okay.
Exactly. 3, 5, 6, 7, 8, 9, 10, 11. I'm basically counting the number of quarters. And then I'm adding that number to another arbitrary date.
Oh, so this is interval. So what's the significance of interval right here? Because it's not a function call. That's what's interesting about it. It's like a keyword-ish thing.
Yes. So basically, I'm saying the date add, if you go to the full line, is to that arbitrary date.
Add an interval?
I'm adding 3 days.
Oh,
4 days.
My goodness. You're only adding single days. So you're completely re-representing, transforming this. You're saying 12 quarters is now just shown as 12 days to the ARIMA model. So it looks like things are changing daily because that's what the tool allows right now.
Yeah. Exactly. That's ARIMA works really well with dates. I'm doing this magic function to go from quarter data to daily data, and then later I go back to quarter space.
Yeah. So it's a space it's a time transform. Fancy.
Exactly. That's the kind of tricks you have to do sometimes, but once you get it, it's pretty straightforward.
Would I personally do this in SQL? Maybe not, but SQL is your native tongue, so.
ELT. Extract, load, and then transform. You can do all of the transformations inside BigQuery, so why not do them there on the fly? The other thing that I'm doing here is that Stack Overflow has thousands and thousands of tags, and just for time purposes, I'm only looking at the top 15,000 tags.
Yeah.
Now, so I'm telling in this query, train this time series only if the tag is one of the top 15,000 tags.
It's a pretty generous limit, given that we only care about the top 10 in the end, right? So that's good.
Yeah, well, on my dashboard you can see everything, 15,000 tags, which is pretty cool because you might want to see closure is a very obscure tag on Stack Overflow. Closure people get angry when I say that, but sorry. Now, the problem with training 15,000 time series and predicting and doing all of that is that it takes time. It's wonderful that BigQuery can pull this off in 20 minutes, but we don't have 20 minutes now to just train and predict, so let's change that for, I don't know, 150? Just give it any number. Yes. See, Preston is saying that I'm SQL Stan. And the other problem, I have this problem with DBT. What I really want to create with this file predict trend SQL is a table with the materialization of all of these trends. Now, you can see that this part of the code is...
It just creates the model.
Inside the SQL header.
Yeah, what
block.
does that mean?
So it means that the main job of this file is not creating or replacing this model. The main job of this particular file is to create the table that you will find below.
Oh,
scroll a little bit.
It's down here.
Yeah, that's my table.
So when does this all execute then? Because I do see that you have this kind of call and end call that wraps.
Yeah, that executes as a header of this table. So before creating this table, DBT knows to execute the code that I have up
so that's
there.
what they mean by what it means by a header. And so, and what you were saying about the file's job being to make a table, it's kind of defined here. To that this file is a materialized table, and instead of running this as a separate, because we could probably put this in a separate file, right? And just tell it to run this.
But then I need a separate file that is of the type model.
Oh, but they don't have that.
And that DBT that has not implemented it naturally.
Okay, so this is how you've kind of slipped it in there.
Yes, that's part of my trick. But the real table that I'm creating here, if you scroll down, is this one, where I'm combining all of the tag views that I already know. I'm doing an union all with change that number so it matches. And I'm doing an union all with my predictions taken out of the just trained model.
Yeah, and I see you have the line to invert what we did before. Now we have the date diff by day, and then adding a quarter to the original date. So even though you said those are arbitrary dates, those arbitrary dates do need to match.
Yes, to do the transformation back into
because those are your limits, basically.
That's part of the SQL stand-up. And this didn't work because if you go back to when I created the model, I had to hard code some strings.
You got a model name, you've got a table name, you got another table name.
Exactly. Usually in DBT, I don't hard code the name of anything, but in this case, in the SQL header, I had to. So now please replace by hand the name of your data set.
Yes. What did I call it? DBT Stack Overflow. I have mine backwards.
Yes. It's backwards, but that's why it didn't work. I had to hard code it, and now this fixes it.
And then the other table is called, let's see, we're looking for tag views and stats tags. So tag views is not currently called that, and stats tags is also not called that. So I need to do...
Oh yeah, but if you refresh the window, you will find the correct tables now because we ran DBT in between.
Oh, interesting. So those tables were updated by DBT already?
Recreated. Yes.
Man, these last couple of weeks, we've really shown how useful refreshing is. Is it broken?
Yes.
Just refresh the window.
Refresh.
Cool.
Ta-da.
So we got stats tags, we got tag views, and so I guess we're good.
Yeah. Now you could rerun everything here now again, or just rerun this model.
Oh yeah, that'd be nice.
We just fixed. Let's see. Yeah. You should have the code for that in
one of these YAML files.
And if you don't have it,
is it this one?
So basically, I'm going to give you the code back on our code tunnel. And you will be able to find it at the top.
Oh, model equals top questions. Interesting.
Yeah, well, we don't want to run top questions now. We want to run predict trends. But that's basically how you tell DBT that you want to run only one model.
Oh, gosh. Misclick. So model equal, and you can just give the file name without the extension. Looks like that's what we're doing, right? It's
yeah.
not top question. It's predict trends. Cool.
We have on ML a question about if BigQuery can use better versions of ARIMA. Spoiler alert, I don't know what Databricks does, but ARIMA in BigQuery is way more awesome than plain ARIMA, and I will show you that in a second. So that's a great question. I have a mind-blowing answer for that.
Nice. Looking forward to that.
Yeah. Yes. So now DBT is actually, it created the model, it trained the model, and now we have our predictions. And that's all it took. Because you were doing 150 tags instead of 15,000,
1% of the time, right?
Exactly. Let's refresh BigQuery to see
the
new
say,
table.
Where is this? What did we end up calling this new table? Select.
The name of the new table is predict trends. That's
so that's what's. Where do we set that name?
It's the name of the
that's
file.
How that
the
that
name of
will.
The file it will be the name
that's
of the
good
table.
To know. Yeah.
Yes. Preston would love to see some XGBoost soon.
Yeah.
That would be fun. And you know a lot about
I know a little bit about XGBoost.
You know more than
me. Predict trends.
Predict
BigQuery
trends.
Does support.
That's the table. And you can see the details of the table. Yeah. Here you can see what I'm using for the data studio
so
dashboard.
This is our raw data. Great.
For each tag. Exactly. For each tag on each quarter, I have the ratio of attention that it got.
Yeah. And you have it split out singularly by quarter. Like there's not multiple columns for quarter, like this quarter. You're not adding columns. So that's, you're keeping it.
You could do a pivot if you wanted a pivot.
Yes.
We covered how to do that last week.
Let's not get too sidetracked.
That would be useful. Yeah. But yes, I also created two other convenience columns, which has what was the ratio for that time series last quarter, and what was the ratio for the time series 3 years from now. And basically, I'm using those in Data Studio to do the ranking. Like sort by...
So that's how you're getting away with the easy sort, right? Like we talked about in that Data Studio show. Fix the data. Don't try to do the magic in Data Studio.
Exactly. It was really hard to do in Data Studio. I just created two convenience columns, and you can see the code there. If you go back to our Cloud Shell
that's right.
editor.
Instead of in BigQuery, now we're over here when we want to look at something. Where's our convenience?
Exactly. That's how I created my two convenience columns.
So it's these two.
Yeah.
So you're saying the max on the specific quarter, the max value of the ratio partitioned per tag. Nice.
Well, then I have a convenience column. Then I can use that in Data Studio. Data Studio is cool. Well, I prefer to work in my code.
Gotcha.
SQL stand. Another interesting thing is that you can find the model now.
Yeah. Where does BQML visualize the model? Is it just in this list?
I created it on temp. If you see the code, the model was created. So go to the dataset temp that luckily you already have.
Conveniently.
Conveniently.
Just
we've been doing this show for a while, so we have some things. That's the model.
After the model training, did I pick the right one? It doesn't think it's done.
Well, remember this is in beta, so all of these visualizations are improving. But you can query the model. Let's get some data out of it.
Yeah.
And And now, to get data out of it, you need to do it in a different way. So you can go to my blog post.
Yeah, I was going to cheat by looking at the query because you actually kind of have it here.
Oh yeah, but you already know how to do forecast. I want to show you some interesting stats
okay.
out of it. Yes. We can do forecast.
All right, where do you want to go in the blog post?
By the way, I have this little chart showing the difference of attention between BigQuery, Redshift, Athena, Teradata, and Snowflake.
Ba-bam.
Which of these is getting more attention? Surprise.
Mic drop. Yes. And the serverless community gets to duke it out over here too. Wow.
Yeah, Lambda is the one getting the most attention, but you can see that Cloud Functions is growing strong. Yes. Let's go find the code to look at stats. So there's how to create a model. We can come back to this code. Here I'm generating some manually some time series to see how ARIMA works with linear trends, square trends, exponential trends. And it does such a good job. Look at that. Half of this chart is the data generated. Second half is what ARIMA guessed. And it looks good. Like, especially the cyclical curve, you can see that ARIMA got it totally right. And here is the answer to: can you use better ARIMA models inside BigQuery? The truth is that we are calling it ARIMA in code. BigQuery is doing so much more than ARIMA. I don't know if you want to read this loud.
Well, I mean, I think the summary might just be, we call it ARIMA, but it's ARIMA++.
Exactly. Let's call out some of the things that BigQuery is doing. Automatic cleaning adjustments to the input time series. With missing values, duplicated timestamps, spike anomalies, abrupt level changes. BigQuery will take care of it.
Holiday effect. That's really cool.
BigQuery knows the holidays for many countries. So you can add that data. You can say, hey, consider the holidays for Chile.
Okay, so you specify
China,
a country.
Or for Singapore.
Nice.
Yes.
We got a seasonal trend using the seasonal trend decomposition using LOES algorithm. What is LOES?
You could click on it and discover it, but yes, it's more ARIMA magic inside BigQuery. I still need to learn these things. Seasonality extrapolation. The double exponential smoothing algorithms.
Nice.
Yeah, and ML says, ML knows this, so I'm glad that they're excited about this. So, yes. And AutoARIMA. AutoARIMA means that BigQuery will look for dozens of candidate models. They will train, it will evaluate them in parallel, and will choose the best one for each time
because a lot of these types of time series algorithms, right, have these underlying input parameters that you can tweak and try out. So that's kind of what this hyperparameter tuning is referring to, is trying different variations of the same underlying formulas with different input parameters or hyperparameters, as they call them, and try to find the base one.
James Ramberry head just exploded on the live chat. That made me happy. So, also, Julian is asking what's the difference between predict and forecast. Most of the models in BigQuery do a prediction.
It's like a one-off prediction.
Exactly. Give me features, and I will use the values of these features to predict. Forecast is just, I'll just do a forecast of this time series. So that's why forecast has almost no inputs.
Well,
we will play with the inputs, but
another way to think of it is like forecast, you are outputting a time series as output. Typically with predict, you output a single value maybe you output a few values if you have multi-headed models, but it won't be a series, right? Like it's not designed for that typically. And so it really comes down to what your data type is. If you have time series data versus more traditional kind of tabular data or categorical data or like decimal data, regression. So
yes, that's a good answer.
And Michael, yeah.
Let's go see.
I was saying Michael Whitaker wants to know if it can reveal the anomalies it found and subsequently cleaned up. But that might, I could see that potentially being hidden under the covers.
Yeah, that's a good question, and I wonder if we're going to get more of this on the beta.
Because it does have
what
this,
I can show
right?
You
it
right
reveals
now?
Those optimal coefficients, so that's something.
Yes, so let's go look at the coefficients for the model we just created.
So we want ARIMA coefficients, model, blah.
So, just copy the 2 lines and...
Get it right? Select star from that model, blah. Still doesn't like it. Oh, because of this.
Yes. Didn't like that comma.
Crazy. What is this?
And here you can see.
So this is
how each tag was treated in a different way.
Do you know what these columns are though? What AR and MA mean?
I don't know exactly.
Either.
But if you go back to my blog post, I can that reveals a little bit out of it. So you can see that I generated 4 time series. One was linear, one was exponential, one was sinusoidal, and one was like a square growth.
Yeah. And you earlier off the air, you were telling me about what ARIMA stood for. Maybe that's what this is. It's AR, it's like R, and then I don't know where the I went. Maybe that's the intercept, right? RE and then ma. Eh?
Yes.
That'll be my guess. Can you repeat what you said to me about what does A and R stand for? Automatic.
ARIMA is auto regression, imagination, materialized understanding. ARIMA is auto regressive, integrated, moving average. Auto regressive, integrated,
moving average.
Moving average.
Something like that, maybe.
Yeah, something like that. But you can see, like the linear one has the simplest coefficient, 10.
Yeah.
Wow, that's a big zoom. And now I can see more of the tail. Yeah, the linear with the coefficient for my linear line was 10. The square one, that's square growth. It's basically 0, and then it has an AR coefficient that is growing.
That's the that auto regressive coefficient, very close to 1.
Yes. The exponential one, ARIMA is not good at finding out exponential growth. So you can see in my prediction
it just went straight.
Basically went linear.
Just like
exactly, it went straight. So if you're dealing with exponential growing curves, maybe ARIMA is not the best model, or you have to do some transformations. That's something good to know. But still, the prediction makes sense. If you were just drawing, I would have drawn a straight line maybe, more than an exponential line. It's what the model does. And you can see that the other one, that the more complex line, the one that has cycles, got more complex coefficients. So, yeah. I cannot exactly explain what each coefficient means, but you can see how it impacts the behavior.
Yeah.
Like, depending on what it sees on the data, it will have different coefficients, and we can apply the same concepts now to the results that we got out of each of our real-life trends. So with Ajax, you can see, that looks like a linear thing, et cetera, et cetera, et cetera.
Interesting. So now we want to somehow plot this, right? If I recall.
Well, I don't know if the plot here will.
Oh, right, not this. Sorry,
work
not
a lot.
literally directly
Yeah.
this.
Yeah. But what we can do now, again with the model, is we can do our forecasts. Yes. Yes, and ML is asking. Oh, they just retracted their message. But yes, I'm glad that ML knows
quite a bit about all this stuff.
Yeah. So what BigQuery offers you, especially here, is one of the simplest, fastest ways to try a lot of options, like do the hypertuning, apply as much as we know, do seasonal adjustments, and output the best answer that it can. It also gives you some levers to fix it. So let's go to the create model for BigQuery docs.
This statement?
We need to open a new tab. Just search Google for BigQuery create model. Just to see some of the levers that we can move. In this case, we move no levers, but I wonder if I can do a time series for my weight. If I could plot my weight, and then I can know what clothes I will need when I'm 90. So there is ARIMA, and ARIMA as an option.
Oh, auto ARIMA.
Yeah, exactly.
That's cool.
These are choices you can make. You can look at the seasonal order. You can. So these are levers that you can move.
You got data frequency.
If you don't trust BigQuery.
Oh, that's a separate one.
Yeah, if you want to improve of what BigQuery does automatically, but for most users, you will get an automatic result. Yay! ML said, oh, cool. Now that they know they have more levers to play with this. Yes. Please, we love feedback, and we love to know what improvements you would like to have on ARIMA before it goes to GA. Now it's beta, so it's the best time to give us your feedback. And I love these questions because they make me wonder what the answer is, and then I'm better at answering them. So let's run a forecast, and let's see what we get out of our time series predictions.
So we had this. I'm going to just steal this line to get us started.
Yes, that's why I have all the code for you to play with.
All right. So we got that.
Yeah. And instead of tag and forecast value, just give me an star. Let's get everything out of the forecast.
Oh, and we still want the date?
Or we will get it if you want it.
We'll leave that out.
Okay, so now we're going to see the raw result of the forecast. And you can see that when we ask for a forecast, show me the code again, please. Just to see what we got here. The options that we had for the forecast is, instead of asking for the next 12 quarters, let's ask for one more day of data, one more predict, one extra. And for the confidence level, choose 0.9.
Okay, so we want high confidence, just the next step. So that's how for folks watching at home, that is how you would get your next kind of, because that's very common, right? You have like a set of data and you just want one incremental time step.
Yeah.
Awesome. So as expected, we have 150 results. So that's always good gut check to make sure we got.
Good. We trained on 150 series, and we got 150 predictions for the next date. And the important part, with ARIMA, I was plotting and I was showing and I was talking this whole time about what value we're forecasting for the next cycle. That's not the most important part when you're running predictions. Jing Jing Long is on
Yes.
the live chat, and that makes me super happy.
So he says that we can search for
and he
this.
has a great answer for
and that second result, hey, we're already here. Assuming this is the one. I don't think. Do you think it's this one or this one?
But yes,
we'll open both.
Let's go back to ARIMA
All
and what I was saying. We are running a prediction about the future. I'm forecasting a number, and it's a forecast. No one knows. So it's way more interesting than the forecast value is the two columns that you will find if you go to the right. That is that with a confidence level of 0.9, 90%, this is a good interval.
Yeah.
And now we are saying that we are predicting that the value for the next quarter, next day, will go between 46 and 51.
Nice, yeah.
And when you're running predictions, that's way more.
Yeah, rather than just having a single number. Yeah, you got to get bounds.
Yes. And that's a way more interesting thing to plot. It's harder to plot, but this is really interesting because people should not just use the forecasted value. People should look at the interval and then make decisions based on that. And you can see that each time series has a different range.
Some of them are quite wide.
Like, exactly. That one is between 12 and 23. That's a very wide range. Others are like...
That's for Angular JS, between 12 and 23. They have no idea where it's headed.
Exactly. It gives you a prediction in the middle, but it could be
But then there are ones where it's less than one apart. Right, between 9.8.
Between 9.8 and 10. Which tag is that?
Let's take a look. API.
API.
Generically
it's
API.
Like, that's a very stable one. Some people
look at this.
The API.
It's between 11.4 and 11.7.
Oh, what tag is that?
Azure.
Interesting.
Let's scroll down a little bit. Let's find another random one. How about this one? Between 15.4 and 16.3. Another tight bound. Google Chrome.
Google Chrome.
That's
that
funny.
One is tight. And show me. Let's run a query to find the one that
let's
has
sort this up.
the biggest difference.
That's a good idea.
So show the editor.
So wait, what are the columns called again? I forgot already. All right.
Yeah, that's why we have the UI.
Prediction, interval. How would we do this? Lower bound. We subtract the two?
Yeah. Upper bound.
So we have this.
Order by the first column. Add a comma.
I don't know. Call it a diff range from order by diff range.
1.
Oh yes.
Perfect.
Oh wait, we need more than that.
We get
I
the
need,
biggest one first.
Sorry, if we just have that, it's going to be a useless thing. We want tag. Maybe forecast value. Oh, you know what we could have just sorted on? I bet we could have just sorted on the standard error.
That's a good one. But
And just for sanity check, let's just include that and see if it is the same, you know?
Perfect.
Nice. Let's do it.
What was
Alright, so here's our diff range. Because the diff was like a raw diff, right? As opposed to, I sorted it wrong. Order by diff range descend.
It's okay, you can go to the bottom of the table too. But those were the most, basically those are like the most predictable,
these
stable.
Are never, these are very standard things. Eclipse, Flask.
No, I know where this is going. I don't see a lot of
Alright, going to the bottom of the list. Python.
Python, exactly. Could go everything between 11 and 36.
11 is the standard error. 36 was the range of the two values. So it does look like it's sorted. Like, look at these numbers. It looks pretty sorted to me.
But so you're not telling me the minimum and maximum that it's predicting for Python?
Correct. I just have the prediction. So it's...
Can you add these two columns?
Well, it would be
what's the minimum and
36, right? So you split 36 across this, so it'd be plus 18 or minus 18. But yeah, we can add it. Do you remember what those columns were called?
Yeah, your query remembers.
Right.
Prediction
All right,
interval
so let's put that... let's just put it at the end. Oh, whoops, sorry. This is what happens when you have keyboard shortcuts for resizing windows. Windows will get resized when you accidentally press the wrong button. Try to press Command C or Command X, and you accidentally hit Alt instead. All right, Command X.
All your OBS.
It's not OBS. This is just, yeah, just screen managers. All right, we run this.
Yeah.
I guess it's finished.
Yeah,
nice.
Well, not fast. So yeah, Python.
Oh, and we're sorting the correct order now, which is great.
Yes. Python could go all the way
464 to 500. But look how big of a difference that is from the second place. Well, this isn't the second highest. This is the second biggest variance, but yeah.
Yeah, you could divide, you could normalize by the forecast value. You could normalize the difference by the forecast value to see if the range is big for that scale or not. But yeah, here you can see that these are the tags that we really don't know where they will end.
Let's see what we got. Python,
can you show me the first
jQuery, C#, Android, C. That's surprising, given how long that language has been around.
No, basically what you're showing me here is that these tags also have a very... Let's normalize. Let's fix this in the query.
We should divide the
diff range by the forecast value.
Like that.
Yeah. Yes.
Iterative sequeling. Oh, things have changed. Oh.
Exactly. These are the ones that have the wider
relative
range,
to their size.
But normalized. Exactly. Angular, Z, Objective, Algorithm, iPhone, Excel, Xcode,
and the fact, so that means that 0.57 means that the highest to lowest, right? That bound is more than half of the predicted value itself. Like, that's a pretty terrible, like...
Wait. No. Show me the predicted values. Just so it's predicting
12 to 23.
For AngularJS between 12 and 23. Yeah, it's a super wide
the value is 18. So it's like, you know, the range 23 minus 12 is 11, right? And the forecast value is 18. So 18, you're splitting 11 across it. So it could be like plus or minus, you know, almost 30%.
By the way, we are almost running out of time, and I need to mention anomaly detection. Yes. How do we do anomaly detection now that we have these models?
Well, we sort of just did it, but I guess that doesn't count.
Exactly, we just did it. This is basically anomaly detection. So what we could do is, we have our prediction for this quarter. This is how you run the prediction for one quarter. And then you have your actual value. You can compare the prediction to what we got. And then we can ask the question, is the value that we got outside our confidence interval?
Yeah, we could say
that would be an anomaly.
The actual value is less than the lower bound or greater than the upper bound, then anomaly equals true.
Exactly, because there are things like AngularJS that we can expect to go anywhere between 12 and 24. And that's not a problem. It's expected for this time series. But other time series are way more stable. So the way to say this is an anomaly is, did the actual value go outside this range?
Yeah. No, that makes sense. It literally is if it's exceeded or fail to meet expectations.
Exactly. And now we have some comments from ML, but if you go to, I'm going to read that comment, but can you go to my code on your Cloud Shell editor? This is the predict anomaly. And that's what I'm doing here. Instead of training with all the data available, I'm training with the data available.
Yeah, minus
March.
1 quarter, right? You're going 1 quarter short.
Exactly. And then I predict for June, and I compare the difference. And that gives you some anomaly detection. And Mr. or Mrs. ML, our friend ML, is saying that if you are dependent time based, you will have an exponential error regardless of NN or AI. You can use feature engineering based on a ARIMA model, often aggregate your data, monthly, day, year to fix. When you do ARIMA, you have to look over all the data. So from what I can see, this is probably the best forecasting model for feature engineering or low volatility, large company, big cap stocks. And the last comment is, you can use this for anomaly detection. Yes.
Yeah, that'd be super interesting to run this through market data and see which, basically you could have the same kind of thing, right? Instead of saying which tags are under or overperforming, kind of which ticker symbols are outside of what you would have expected based on the historical performance.
Exactly. What are our surprises for today? We could have done this with weather data too. And some stations will be super stable. Some are very flaky, but ARIMA can capture that on the interval. And then you can look at anything that goes outside of it. And you can say, was this a crazy day? Or was this our sensors going crazy?
And but it tells you, for folks who are doing and tracking their own be steps, running, biking, whatever sport, you could build a time series data set out of that and kind of see how you're doing. If you feel like, oh man, I was so slow today, but it's still within the bounds of your typical performance, then it's hey, don't be so hard on yourself. It's okay.
You are a runner. You would do that. Yes.
I have probably over a decade's worth of data. So that might be.
But look at that next.
That'd be fun.
In 2 weeks. Yeah. Let's see what we do. That would be a really fun thing. With that, we say thank you
thanks
to
everybody for joining us.
Joined us today. Please send us your questions, retweet us, tell your friends, show them this video. The recording is available now.
They can come to this link, they can rewind it, they can skip through it, they can find what they need, learn how to use ARIMA and learn how to use BQML to do all the different tasks. I think we showed a handful of different capabilities here that you can try out. We won't recap them for time's sake, but thanks everybody for joining us.
Yep. And if everyone is wondering, I'm using a very appropriate t-shirt today, which is that I'm traveling to the future at regular speed.
That's right.
That's what we do with our predictions.
Right. One time step at a time.
Yes.
All right.
Have a great week, everyone. Stay safe. Thank you very much.
Great. Bye-bye.